So I decided to do all my solving by factoring videos as one big video. So this one may be a little bit longer than the other ones. If you know and there's 4 examples. If you know there's only one in particular you want to see, then you might want to just skip ahead to that one so you're not watching all of these and getting really bored. Also at the end, I'm going to show you a way you can use your graphing calculator to check your solution. So if you just want to see that part again, maybe you just want to skip to the end. Okay, so here we go with our first example. So solving by factoring, you'll see an equal sign. They may give you directions, find roots, find zeros, find x-intercepts. All those mean the same thing. No matter what, you always want to make sure you're equal to 0. If you're not equal to 0, don't even bother factoring. It won't get you anywhere. So be equal to 0 first. And then as we've discussed in our factoring videos, always start with your greatest common factor. So in this case, both of those terms are divisible by 2, and they have an x squared in common. So I'll factor out a 2x squared. And what that means is I'm actually dividing that out. So what's left over is going to be a 2x and then plus 5. And that's been factored completely. Remember in our previous videos we talked about factoring completely. As soon as you get down to x to the first power, unless you missed a greatest common factor, you're done. So this one has been factored all the way. But because it says to solve, because there's an equal sign, we have one step further to go. I'm going to draw lines between my factors. And I'm going to put a line between the 2 and the x squared this time, although most people don't do that. And so what we've talked about previously when you're solving by factoring, if those 3 pieces are being multiplied together to equal 0, what that means is one of those pieces must be 0. So either 2x plus 5 equals 0, so that'll get us a solution, or x squared equals 0, that'll get us a solution, or 2 equals 0. The reason I wanted to separate is to talk about that too. Well, of course, 2 never equals 0, so that's not going to get us any solutions. You only get solutions where your variables are. For the piece on the right, let's finish that. If I subtract 5 from both sides, I'll get 2x equals negative 5, and then divide by 2. So x is equal to negative 5 halves. So there's one of my answers. For the middle portion, then I have x squared equals 0. I'll take the square root of both sides. And normally when I take a square root, I would put down a plus or minus. There's no such thing as plus or minus 0, so my answer is just going to be 0 for that piece. So there are my answers. My roots, my solutions, my x-intercepts are going to be 0 and negative 5 halves. Well, some of you know how to tell how many solutions this problem will have. Some of you have worked ahead or you're watching this as a review video. And so you know we've talked about this, that the third power means you have 3 solutions. And so some people get really confused and they say, well, where's my third answer? It turns out that because x was squared in this piece right here, that 0 actually counts as a double solution. So you don't need to list 0 twice. Just in case you're like, if you're like me, or like some people that want to know, where's your third answer? 0 actually has to be counted twice for the fundamental theorem of algebra to work. So there's my solutions. There's all 3 of them, even though I only see 2. And again, at the end of the video, I'm going to show you how to check these on your calculator. Next example, let's solve this one by factoring. Once again, be equal to 0. If you're not equal to 0, get it equal to 0. Don't even bother factoring if you're not equal to 0. It won't help. So greatest common factor first. This time everything has a 4x in common. So let's factor out, let's divide out a 4x and see what we're left with. So divide all the coefficients by 4, and then everything will drop by a power because I'm taking one of the x's out. So x to the 4th minus 10x squared, and then plus 9. Equal to 0. Well, that's not factored completely. I can keep factoring this one. It's a trinomial, and there's a 1 in front. However, the exponents are higher than what they normally are. But like we talked about in one of the previous factoring videos, I'm going to pretend in this case. Pretend it's a normal trinomial. Pretend it's just x squared minus 10x plus 9. So I need 2 numbers that multiply to 9 but add up to 10. The 2 numbers that are going to do that are going to be negative 1 and negative 9. So I'm going to put those down. In my parentheses, though, I was pretending. At this point, I have to come back to reality, and remember, it wasn't just x in the parentheses. It's going to be x squared, because x squared times x squared would get me x to the 4th power. Okay? I still want to check for more factors. Because it's x squared, I probably want to look for a difference of 2 squares, and it turns out that in this case, both terms, or both parentheses, are difference of 2 squares. They're both subtraction problems, and negative 1 and negative 9, or 1 and 9 are both perfect squares. So I can factor again. Don't you love these problems? X squared minus 9 would factor into x minus 3 and x plus 3. Remember, we take the square roots and then I change the signs. If you need help with factoring, I highly recommend you go back and watch some of those factoring videos. X squared minus 1, the square root of 1 is just 1, so this will factor into x minus 1 and x plus 1. And then I've got that GCF in front still of 4x. So I end up with 5 total factors, 4 parentheses, and then that 4x in front. So what I want to do is I want to draw lines between each of these parentheses. Any of those could get me an answer. I've already seen x will get an answer. And as we discussed in the last example, if you watched that one, this problem should have 5 answers, and so I'm going to get all 5 of them this time. Since all that stuff's being multiplied together to equal 0, I know that one of those pieces must be 0. So maybe x plus 3 equals 0, which would get me negative 3 as an answer. I'm not going to write this out for all of them because most of you know the shortcut at this point, just change your sign. Maybe 3 is an answer. Or I shouldn't say maybe, I mean 3 is an answer. Also, negative 1 is an answer. Oops, can't really see that. Negative 1, but there is. And this gets me 1 is an answer. So there are 4 of my 5 answers. Finally, this piece in front, I'm just going to say 4x is equal to 0. And so if I divide both sides by 4, I get 0 as my 5th answer. So remember, that highest exponent tells you how many you have, how many answers you have. I have 1, 2, 3, 4, 5 answers this time. Again, if you want to skip to the end, I'll show you a way to check these using your calculator. All right, let's take a look at a third example. And again, feel free to skip around in this video if you don't want to take the time to watch all the examples. So as we've been saying, if you have been watching all the examples, don't even bother factoring unless you're equal to 0. So in this case, I was not equal to 0, so I need to subtract that 2x over. You can probably guess I'm not going to write it at the end necessarily. I always want to be in descending order. So I'm going to say negative 2x and then plus 12 equal to 0. Okay, so once again, now that you're equal to 0, start with a greatest common factor. There's nothing that all 4 terms have in common. Some people try to take an x out, but that 12 at the end does not have an x, so they don't have anything in common. With 4 terms, the way we factor this was we used the grouping method. And once again, if you need help with the actual factoring step, go back and watch a factoring video. I'm not teaching factoring in this one, just teaching solving. So I'm going to assume you guys are okay with grouping. Remember, I showed you a different way to do grouping with the box method. If you want the traditional way, or if you know the traditional way, then go ahead and use it. But the way grouping with the box method works was put your terms in the box, all 4 of them in order. So x to the third, negative 6x squared, negative 2x, and then positive 12. And what you're doing is looking for greatest common factors across the rows and across the columns. So the bottom row has a negative 2 in common. I could divide both of those by negative 2. Top row has x squared in common. Looking across, or looking up and down columns then, those can both be divided by x, and those can both be divided by negative 6, remembering to match signs on the outside. So your factored answer should be x minus 6. And then x squared minus 2. Now you may want to try factoring that x squared minus 2 using difference of 2 squares. It is a difference problem, however, 2 is not a perfect square, so that cannot be factored anymore. This is factored as far as it can be. However, factoring was not what they were asking us to do. They asked us to solve this one. So draw a line between your factors and put each factor equal to 0. So x squared minus 6, or x minus 6 equals 0, and x squared minus 2 equals 0. One side is easy. It's what we've been doing all along. This is just going to be 6 as one of your answers, so that's 1. On the other side, I have a little bit of work to do. I'm going to add 2 to both sides, so x squared equals 2. And then I need to take a square root. Now, 2 is not rational. I've never wanted decimals. I still don't want decimals. So leave it the square root of 2. Simplify it if you can. We can't simplify square root of 2. So we get 2 answers. Those of you that know about the fundamental theorem of algebra, though, know that there should be 3 answers to this polynomial. So you may be wondering where the last one was. Well, remember, when you take a square root, there's always 2 answers. So we have a plus or minus in this case. So positive square root of 2, negative square root of 2, and 6 are my 3 answers. And one more time, if you skip to the end of the video, you can see a way to check this. All right, and one more example by solving by factoring. If you've watched every single example so far, good for you. It's probably super boring, but good for you for seeing lots of different ways you can solve by factoring. Remember, they may be saying find roots, zeros, x-intercepts, whatever. So we want to be equal to 0 before we do anything else. So let's do 3x to the 5th. I'm going to subtract off that 18x to the 3rd, and of course put that in between because I want to be in descending order. So plus 15x, and now I'm equal to 0. Always start with greatest common factor. That's what's nice about using the flowchart. It tells you right away, look for greatest common factors. There's a 3 all terms can be divided by, and everything has an x in common. So what's left over then, once I divide out of 3x, is going to be x to the 4th minus 6x squared, and then finally plus 15 equals 0. Okay, again, according to your flowchart, we have 3 terms, so we're going to try to factor this as a polynomial, or as a trinomial. There's a 1 in front. Although my exponents aren't what they usually are, I'm going to pretend. So I think our first example was just like this if you watch that one. I need to find 2 numbers that multiply to 15 and add up to -6. If there was not a 1 in front, I would need to use the box method to factor this. So I'm pretending it's normal and just doing what I normally do. Multiply to 15 but add up to -6 are going to be, oops, I'm sorry. Whoa. Let's hold on a second. Not multiply to 15. I forgot to divide the 15 by that 3 I took out. This should just be a 5 right there, not a 15. Oops. Did you yell at the video to make me fix that? Well, there, it worked. Look, I fixed it. So that should be a 5 right there. I'm sorry. So multiply to 5 and add up to -6. That'll work. So -1 and -5 are the two numbers that will do that. Now, normally it would just be x minus 1 and x minus 5, but because we were pretending, I need to go back to reality. Those need to be x squareds because I need that first term to be x to the 4th when I multiply. So x squared minus 1 and x squared minus 5, and then that GCF in front. Once again, I want to look for more ways to factor. I can try difference of two squares. X squared minus 1 is the difference of two squares. 1 is a perfect square. So I can factor that into x plus 1 and x minus 1. You may think, well, x squared minus 5 is the same way, except 5 is not a perfect square. It would be a decimal if I tried to take the square. It would be irrational. So x squared minus 5 would stay the same. And then finally, don't forget that GCF in front. So that polynomial has now been factored all the way. However, they didn't want me just to factor. They wanted me to actually solve this. So let's draw our lines between our factors. These parts were easy. We're going to get -1. We're going to get 1. We've talked about y in the other examples if you watch those. This first part, if I write 3x equals 0, I'm going to get 0 as an answer. So I'm up to 3 answers. I've got 0, I've got -1, I've got +1. Many of you know that there should be 5 total answers because my degree is 5. So there's still 2 that are missing. They're going to come from this final parentheses. So x squared minus 5 could equal 0, which means I'll add 5 and then take a square root. As we said in the last example, if you watched it, I don't want to get decimals, and square root of 5 would be. So let's leave it as square root of 5 and simplify it if we can, but 5's prime. And remember, anytime you take a square root, there's going to be that plus or minus. So that's where my remaining 2 answers come from, positive square root of 5 and negative square root of 5. All right, so there's all my factoring examples. Hopefully that's been enough for you to try some and see a few. I want to show you one more thing, and that's how to check these using your graphing calculator. So let's just use this as our example to check. All of them can be checked the same way. So let's switch over to the calculator, and I'll show you how to check on there. So let me give you a couple ways that you can check your solutions when you solve by factoring using your graphing calculator. So here's the last example we just did. I've gone ahead and I've typed in my polynomial once I rearranged it to get it equal to 0. So this is what I want you guys to type in as your y1. Now, one way you could sort of kind of just get a rough idea of if you graphed or solved correctly is just to graph your polynomial. Remember, we're saying that the solutions are x-intercepts. So we can kind of eyeball and see that, yeah, it looks like it crosses at 0. It looks like it crosses at 1. It looks like it crosses at -1. The square root of 5 one's harder to check. So the better way to check is actually to check your table. One thing that I want you to do first, though, is adjust how your table works. So press second window to do this. And what I want you to do, you probably have this on auto, unless you've done some other problems like this before. I want you to change that independent variable to ask instead of auto. The independent's your x value, and so changing that to ask, what that'll allow you to do is just type in the x values you want to check. So not just, you won't have to scroll through to find them. Also, you'll be able to type in the weird ones like the square root number. So change that to ask. When you go to your table now, it'll probably be empty. There may be stuff in there from before, you could just type over it. But what you're going to do is type in the values you want to test. So we got -1 as a solution. The way you'll know if it's right is if a 0 pops up in your y column. So -1 is in fact a solution. Let's say that you made a mistake and you got 6 as an answer. We would know that 6 wasn't going to work because look, 6 doesn't come up as 0. So you can test all the ones that we try. We kind of eyeball them from the graph as well. However, these irrational ones, you can also test those. Just type in the square root of 5. And look, it'll check that as well. It changed it to a decimal, but look, it checks out. That's a 0. As well as the negative square root of 5, we can check that. So, you know, it's a quick, easy thing to do. It's worth doing just to make sure that you didn't make any mistakes in your answer.